Hello, hi, welcome. Welcome to Unacademy. Crack Gate Computer Science with us, top educators, quality content, great learning experience. Let's crack Gate CSE. Our anthem is Crack Gate and ESE with India's largest learning platform, none other than Unacademy. Get Plus subscription and access unlimited live and recorded courses from India's best educators. Myself is Srinivasarao IS, having 17 years of GATE experience in the subjects of database, computer networks, and operating system. Also had certifications in database admin, Cisco, Red Hat Linux, and Microsoft certified system admin. Also had industry experience as a database admin and a system admin. Throughout my journey of GATE, I taught in many premium academies like GATE Forum, the GATE Academy, and MadeEasy too. And my participation to bring the students, to enable the students to understand carefully and get good success. I'm also part of single and double digit ranks. If you get the subscription, you're going to get daily live classes, live test and quizzes, structured courses, and unlimited access. Using unlimited access, you can get live sessions as well as record sessions. As far as GATE and ESE concern, there are multiple courses are available in CSIT stream. As far as subscription concern, there are two kinds of subscriptions, 12 months and 24 months. If you apply my promo code Sankara, you will get 10% off on the subscription. As we know, we are running full course of DBMS on YouTube on behalf of Unacademy. The channel name is Let's Crack Gate CSC. Search for name S. Srinivasarao. You will find all my lectures regarding DBMS, networks, and OS. And evenings we are doing special classes on MCQs of various chapters of database management system. Now, coming to today's session, we are going to discuss about different kinds of dependencies which are available in the schema design process of database management system. A schema is nothing but an object, and every object is also called as an entity. An entity is having or associated with some of the dependencies. The dependencies are fully functional dependency, partial functional dependency, transitive dependency, and overlapping dependencies. If you have or a schema is associated with some kind of functional dependencies which I mentioned below, then there are some problems. Each dependency is producing a redundancy. We are doing schema design with the help of normalization in order to achieve a non-redundant database. But if the schema is associated any of these dependencies like fully functional dependency or partial functional dependency or a transitive dependency or overlapping dependencies, these dependencies are leads to have redundancy or leads to have redundancy in the particular schemas. Therefore, we are trying to avoid these kind of redundancies in order to have a non-redundant database design. As the name normalization implies that your schema is free from unwanted or uncontrolled redundancy. The redundancy can be controlled only with the help of normalization. But apart from that, if your schema is associated with any kind of these dependencies, then there may be a chance of redundancy. Today we are going to discuss about if at all a schema is suffering from either of these dependencies, then we will understand it's 100% suffering from redundancy. So this problem, how you're going to overcome? To overcome those problems is nothing but normalization keeps the breaks in order to avoid this redundant data. Therefore, you will see that non-redundant data just by decomposing. So when you do the decomposition, then you are going to have the breaks to the redundant data. Then you will find that non-redundant data. So we are going to learn each and every functional dependency. So the different functional dependencies as shown in the previous page, fully functional, partial functional, and transitive dependencies as well as overlapping dependencies. If you look at the first functional dependency, that is fully functionally dependent. If you are taking a fully functionally dependent, you will say that 100% your redundancy is 0. Why 100% your redundancy is 0? Because the fully functional dependency is telling you that you never see a concept of redundancy in that. That's why the redundancy in fully functionally dependency is 0. How do you identify whether the dependency is fully functional dependency or not? So as the definition is saying like this, when there is a production X implies Y is said to be fully functionally dependency. If the removal of any attribute from your X, then X implies Y is invalid. What is the meaning of that? A dependency is said to be fully functionally dependency if the determinant of the dependency is either a candidate key or a super key. Therefore, you feel that this X implies Y is a fully functionally dependency only when either X is a candidate key or a super key, or you say that if you extract any attribute from this X, then X implies Y is going to be invalid. This is what is the meaning of fully functionally dependency, friends. Now, let us have one small example in this. So in this session, we are trying to learn the theoretical definitions and we will prove that there is some redundancy or there is no redundancy using different kinds of realistic examples. So please follow me carefully. As far as this, there is a relation R which consists of the following attributes. And it's given that SNO and PNO is a candidate key and the dependency is given like this: s number comma p number implies city comma status. He is asking find the what type of dependency it is. You can easily confirm that. I said as per as the previous concern, x implies y. To prove as it is a fully functionally dependent, this x is here nothing but, as we are proving, x implies y. Here x is nothing but, as far as given functional dependency concern, s number and p number. So what the definition is telling you, if you extract any attribute from your x, then x implies y is invalid. If I am saying that if I remove this s and o, then your x is only what? P and o. Therefore, what is the functional dependency here is if P and O implies your city comma status. This is wrong. Why it is wrong? You all will come to know what is a P and O. As far as the previous session concerned, as your candidate key is SNO and PNO, therefore your PNO is in this case is a part of key. It is not a candidate key. Then when a part of key is implying your non-keys, and here also this is a non-key, then we will understand that this particular production is not fully functionally dependent. Why? Because your non-key depends on your part of key. So what is a fully functionally dependent, friends? So when you eliminate some attribute sets from your LHS side, then LHS implies RHS is going to be invalid. That's why Fully functionally dependent means don't try to extract any kind of attributes from your LHS as far as this concern SNO and PNO. Therefore, SNO PNO is totally implied all other attributes. So in that case, you want to prove that this X implies Y in the sense we will prove as it is only. Here, your X is giving here that SNO comma PNO is considered as X in this case. Then your X implies Y. Here the Y is nothing but one is a city, and once again SNO comma PNO implies status. Friends, therefore, this we can confirm as a fully functionally dependent because if you subtract either this attribute or this attribute, then the functional dependency is not going to be proved. Hence, we are not going to eliminate either SNO or PNO from your LHS, as LHS is nothing but set of attributes which is denoted with your X. Okay, friends. So by subtracting or removal of any attribute set from your X, then X implies Y becomes not a fully functionally dependent. It is going to be, we know, as far as this example concern, it is a partial functional dependency because your part of key is implying to non-key. So what is the advantage with fully functionally dependent? Fully functionally dependent guarantees that your non-key or part of key is 100% depends upon your candidate key. Therefore, as per as previous definition concern, the redundancy in the fully functionally dependency is 0 as your RHS is completely depends upon your LHS. Okay, friends. Now let us go to one more example. So what is this example is the R is given with S number, P number, city, status, quantity, and he has given some dependency here that S number comma P number implies city comma status comma quantity. So he is asking what is the key for this. We all know that the candidate key in this is SNO comma PNO. You know how to compute. So you understand this is your LHS is implying, please understand, your LHS is implying your RHS. You see that your RHS is completely depends on your LHS or part of your LHS or part of your candidate key. As far as we concern, we know that SNO comma PNO as it is candidate key, then LHS is a candidate key, RHS we don't mind. So RHS may be a non-key or RHS may be a part of key, we don't mind. So therefore, this is 100% fully functionally dependent as because your dependents are completely depends on your candidate key, not on part of candidate key. Okay, friends? So we want to have a proof that fully functionally dependent is free from redundancy. Why and how? Please observe carefully. As far as previous concern, the candidate key, we guess that SNO and PNO. So using the same scenario, I am following S number, P number, city, status, quantity. So we understand this and this together is your candidate key. Therefore, the result is supposed to be unique. S1P1 unique, S1P2 unique, S1P3 unique. So if you want to give S1 once again with the combination of a P1, this and this. We will understand that this is a what? Invalid entry. Invalid entry as S1 and P1 are already is coming as one more time. Hence it is called as redundant production. So it will not allow you to enter this record because you said that SNO PNO is a candidate key. When it is a combined candidate key, then what will happen? You cannot have the duplication on the same attributes. So here two column candidate key is there. So S1 P1 production is already there. Tuple. So you cannot give S1 and P1 once again. Therefore, you can control redundancy in that. That's it, friends. So you will understand that 100% fully functionally dependency is free from redundancy. Okay. So we always see that our schema is supposed to have fully functionally dependencies are preferable. So normalization process is telling you that don't have the concept of partial functional dependency, transitive dependency, and overlapping dependencies, as those three are leads to the concept of redundancy. So we all feel that the fully functionally dependents are only preferred in the schema design. So what is the responsibility of your normalization is nothing but elimination of partial, elimination of transitivity, elimination of overlapping dependencies, and try to sustain as much as possible fully functionally dependents, as the fully functionally dependent is saying that 100% redundant free, as all your non-key attributes depends on your candidate key. Okay, friends. Now let us see one more example here. I'm saying there is a R which is having three attribute sets like A and B and C. Now we have some tuple set A1, B1, C1 against to these three attribute sets. And he mentioned some of the functional dependencies I am taking. These are all assumptions only. So I am taking some functional dependencies are here. A implies B and A implies C. Friends, you will understand what type of dependency it is. We will understand that this non-key and this C is also non-key depends on directly. If I am saying let, as per as this concern, your candidate key is, you will get it as A. As candidate key is A, then you will come to know that your non-key depends on candidate key and your candidate key implies non-key. In that case, both dependencies are fully functionally dependent only. Friends, so what is the advantage? As this we identified as a candidate key, then if you try to enter a duplicate here, it is not possible because candidate key is trying to have non-duplicate data. So you cannot have duplicates in that. So this is the advantage with what? Fully functionally dependency. The redundancy with the fully functionally dependency, you can go what? 0%. No doubt in that, as your dependents RHS completely bound with your candidate key column only. This is an idea. If you look at another type of dependency, partial functional dependencies. So dangerous as they are going to create much redundancy in your schema. So we are trying to break this partial functional dependencies. So we are trying to remove these partial functional dependencies by using the mechanism called decomposition of your normalization. So we use decomposition mechanism to avoid is partial functional dependencies. So decomposition mechanism is one of the mechanism of your normalization. I already said normalization is going to remove partial dependencies, transitive and overlapping dependencies as they are providing or generates redundant data. So once you remove those three dependencies, you will get non-redundant data in your schema design. When you are redundant free, please follow the previous lectures. When you are redundant free, you don't have anomalies, you don't have inconsistency, you may not feel data dependency problems. So you will get 100% free from all the problems as and when you have non-redundant data in the schemas. Okay friends, so what is the concept of partial functional dependency? When you have the partial functional dependency, it's a very simple that your LHS is supposed to be part of key and RHS is supposed to be non-key. So a dependency is said to be a partial if the non-prime attribute of the relation is getting implied by part of your candidate key, and so you will see a situation part of key implies non-key situation. So that is example is here. Let x tends to y is said to be a partial functional dependency if and only if x is a part of key and y is a non-key attribute. What is the problem with this partial functional dependency, friends? It's not only giving you inconsistency, it also provides high redundant data in your schemas. Therefore, you are responsible, or we will follow the normalization technique to eliminate these partial functional dependencies. Therefore, you will get non-redundant schema. So, friends, you need to understand carefully the main problem with partial functional dependency is nothing but it started providing generation of huge redundancy in your schemas. So, how a partial dependency is going to give you redundancy? We would like to learn with a proof. Observe friends. So you want to say that partial functional dependency, please observe there is a one hint I want to provide. What is the hint? To say that partial functional dependency you want to say, you see that your non-key is getting to be derived from part of key only. Therefore, to prove the partial functional dependency, your candidate key must have minimum of two prime attributes. Minimum of two prime attributes. So prime attributes are nothing but your part of some candidate keys only. Therefore, key must be composite. Indirectly, I am telling you that what? Key must be composite. It must not have single. If you are having a single, then you are not having to prove partial functional dependency. You're above that. Please understand. You want to prove partial functional dependency, it's 100% see that your key must be what? Composite only. Clear? Now, as far as this concern, what the type of dependency it is. So we want to find out candidate key from there. So your candidate key, as far as that, directly you can say AB and your prime attributes from there A comma B, and non-prime attributes from there you can say C comma D. Okay friends, now look at the first production. The first production is AB implies C. So C is nothing but a non-key as it is listed here. Non-key depends on your candidate key, and it is directly you can say that fully functional dependent only as your non-key depends on your candidate key. The second the second production, that is B tends to D. Here B is nothing but one of your part of your key, and I can say this is a non-key and B is nothing but your part of key, and so we can confirm it's not a fully functionally dependent, it is a what? Partially functional dependency. As far as that, your candidate key is AB, and what is the type of dependency you have? Partial functional dependency. Okay, friends. So this is what is the meaning of partial functional dependency. Now let us look at another example. We will see the proof how it is generating redundancy. First, let us understand the type of dependency we are getting in the schema. So as far as this, your candidate key is, so simply I can say S number and P number combination is your candidate key. So please watch my previous lecture if you have any doubt in the computation of candidate keys. So your prime attributes in that are S number, comma, P number. And your non-prime attributes are remaining city, status, and quantity. So the first production which is given like this, S number to city. We are very confident now. Right hand side non-key, left hand side is a part of key. Hence this is partial functional dependency. And the second one is also same. This is the first production, and second one is also your P number implies status, which is also partial functional dependency. And the third production, that is S number comma P number implies quantity, which is nothing but, as this is a candidate key, then we can directly say that it is fully functionally dependence. So we will write here that it is fully functionally dependency. So friends, why I am highlighting this? You never have any redundancy in the production 3, but you have the redundancy in production 1 and you have the redundancy in production 2. There are two kinds of productions here. You are having redundancy, which leads because they are what? Partially functionally dependent. So how will you get redundancy? I will have a proof in the next example. See this now. So as per as the previous concern, previous example, the candidate key is S number comma P number. Observe friends, why partial functionally dependent will give you a redundancy. So I am providing you proof. Understand carefully. So here, as S number and P number is a key, then you cannot have duplicates in that. S1 P1 unique tuple, S1 P2 unique tuple, S1 P3 unique tuple, S4 P1 unique tuple. It's perfectly all right. Why? Because your first production S number P number implies all other productions. Therefore, in this we will find no redundancy. Okay, friends. But what about next two production? The next two productions are like this. So S number implies, please look at the previous page. What is the production? S number implies city, P number implies status. Observe friends, why this is giving duplicates. We know that every functional dependency is going to generate redundancy. Please follow my previous lecture, redundant, how you are going to get the redundancy. There are two factors for redundancy, functional dependency and multi-value dependency. As far as this is one of the functional dependency which is not fully functionally dependent. It is only what? Partially functionally dependency. Therefore, there may be a chance of redundancy in this. How come? Let us see. So city depends on your S number. So first S number is S1. I am taking, please understand, I am taking first S1. Then I am taking once again S1 as per as the given. Again I am taking S1 here and I am taking S4 here. Observe friends, the functional dependency you want to prove, whenever LHS value is unique, we don't mind about RHS. As the first time S1 is coming, the bound city value is VSP. So you want to prove this S number tends to city. Whenever S1 is repeated, VSP has to repeat. Please observe carefully. So we have repeated once again VSP. Again, whenever S1 is repeated, again VSP has to be repeated. Therefore, you will see that one more redundant data. So again it is repeated. I marked with the red color. But S4 is a unique value. You can have anything apart from that. Therefore, what do we understand, friends? This is going to give you, see, this is going to generate what? Redundancy. So, partially functional dependency is going to give you redundancy because your non-key depends on your part of. Friends, one more dependency is also given in the previous example, that is a PNO2 status. So we want to prove that PNO implies status. Please observe, friends, what is a PNO implies status? I have PNO. So as long as PNO is unique, we don't mind. But whenever PNO is redundant, you have to redundant status. So first PNO is a P1 is given in the table, and second is a P2, and third is a P3. You can have any values in the status, we don't mind. But whenever you have P1 is repeating, please observe. So whenever P1 is repeating, then its bounded value should come. So status 10, here also it has to repeat with 10. This is what is the concept of what? Redundancy. But P2 and P3, as they are not repeated, we don't mind. But we are looking at this only. So you will find that having concept of redundancy. So friends, what do we understand? The partial functional dependency, the non-key depends on your part of key. Hence, in order to prove that partial functional dependency productions, then automatically whenever your part of key is repeating in the data, your non-key is supposed to repeat. Therefore, you will find some kind of redundancy in the table itself. This is what is the problem of partial functional dependency. So what to do? In order to avoid this partial functional dependency, what to do? We want to eliminate. How will you eliminate the partial functional dependency, friends? I said, just to use the concept of decomposition of normalization mechanism. When you do the decomposition, then you won't have the concept of redundancy. So how to do decomposition? Let us see. And how to avoid partial functional dependency? Let us learn. See, friends. So this is the diagrammatical approach, how it is partial functional dependency. You observe that let xy is a candidate key here, x and y tends to a. I can say that it is a partial functional dependency as a is a non-key here, which is depends on part of key. So whenever you have this kind of a situation in your R, this is completely belongs to your one schema only. In your R, then we can say that it is a partially functionally dependent. Therefore, you have to remove it. Our main intention is dependent only. Whether dependent, this is A, this in this case dependent is A. Whether your dependent is depending on complete key column or half of the key column. If your dependent is depending on complete key column on XY, then it is a fully functionally dependency. If your dependent depends on only on half of the key, then it is called as partial functional dependency. So partial functional dependencies are so dangerous, they are going to produce vast redundancy. So now we are going to learn how to eliminate them. So the next one is transitive dependency. Before going into that, I will tell you how to eliminate. How to eliminate partial functional dependencies. Elimination of partial functional dependencies is the concept. This is only can be done using a decomposition mechanism. What to decompose? Just eliminate partial functionally dependency production from your relation, from the relation R. This is what is the meaning of decomposition. As far as the previous example concerned, look at friends. So S number, P number, city, status, quantity I am doing here also. So your table is S number, P number, city, status, quantity, which has got few functional dependencies as he mentioned. S number to city, P number to status, and one more production. S number comma P number implies S number comma P number implies quantity. Please write down. So we understood and highlighted this and this both are belongs to partial functional dependencies. So we want to remove from your original relation so that you don't find redundancy in that. Therefore, you will find a non-redundant data. This elimination is only possible with concept of decomposition mechanism. Simply, you eliminate PFD production from the given relation R. As there are two productions here, one production PNO2 status, another production SNO2 city, you have to eliminate them. Therefore, after elimination, you observe friends, this is your original R, which consists of S number, P number, city, status, and quantity, which is decomposed into three subrelations. One subrelation SNO implies city. This is the partial functional dependency production. So I am removing it and name it as R1. And another production is there. What is that? PNO implies status. This is your another partial functional dependency. So you create it as separate table. And the rest of the table you do. What is the rest of the table? I will show you. Look at this. So your R1 this time S number city, which has got only two columns friends, and functional dependency is S number implies city only. So in that case I can say that your candidate key of your R1, there are only two columns are there, SNO and city. S number implies city, therefore your candidate key of your R1 is what? Only number. So now you see, as it is a candidate key in that, let us post the data of the previous. What is the data of the previous? S1, 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 S4. Please observe friends. So I am writing the data in S1. S1. When I am entering S1, it is not possible. Why it is not possible? As you say that your S number is going to treat in this subrelation for R1 is a what? Candidate key. Hence I cannot have duplicates. So here having only one more unique tuple, that is a what? S4. So S1 city you write down VSP only. So S4 city it is a Delhi. Therefore friends, you see that this is the unique tuple number 1 and this is a unique tuple number 2. You don't have redundancy in this. Clear? But you look at the previous, what is that? You're having three S1s, but in this case we are posting only one S1 as SNO is a what? Candidate key. Okay friends, and the second table, it is PNO and status. We are pulling that production and creating a separate table. So therefore your R is not having any partial functional dependency. R maintains only fully functional dependent productions. So your new table is PNO and the status. So this candidate key in this is PNO because there are only two columns in the relation to decomposition 2, that is PNO and status. Your functional dependency is PNO implies status. So PNO is implying your all other attributes, that is status, and PNO is called as a what? Candidate key. Now you post the data. Let us look at the previous given table. There are P1, P2, P3, P1. P1, no problem. P2, no problem. P3, no problem. But P1, it will not take because already we have got the P1 data. So we are going to maintain non-redundant data in this. So P1 status, he has given some numbers there. We will take those numbers here. 10, 20, 30. 10 unique, 20 unique, and 30. So since I am not bringing P1 again, so I am not going to bring 10 once again. But in the previous example, what will happen? As you are bringing, P1 here once again, therefore you are bringing 10 once again to here. So that problem is not there because PNO is a candidate key in that. Therefore duplicates are not allowed. So you see that all the three tuples which I mentioned here are completely what? Non-redundant only. Therefore, friends, you got two partial functional productions becomes now city is depending on your candidate key. Please observe, friends. SNO implies a city. Here, city is a non-key and SNO is a candidate key. Therefore, this function is fully functionally dependent. So we have brought your partially functionally dependency to fully functionally production. In the same way, there is a production called PNO tends to status. We understand that as this is a candidate key and this is a non-key, therefore non-key depends on your candidate key. It is also fully functionally dependent. So decomposition is one of the mechanism of normalization telling you that whenever you have partial productions, try to construct them as a separate tables and pull that production. Therefore, LHS becomes a key and PFD becomes FFD. So in FFD, you don't have the redundancy of the data as this is the proof. You don't have any kind of redundancy. Okay, friends. So what about rest of the table? You please see that your one of the dependent status came and one of your dependent city came. So you remove from your R. Please observe. Again, I am telling you this dependency, one dependency is a status. Remove the dependent column from your R. The city is also another dependent RHS. Remove it because already they are appeared in R1 and R2 respectively. The rest of the table is a what? Remaining columns. So your R3 is having a 3-column table, S number and P number and quantity. Okay friends. Now you observe carefully. I am going to reveal one more important term. So in order to do the decomposition, what is the mandatory? Natural join you will do. What is the mandatory in natural join? Natural join is telling you that there is a requirement of a mandatory. What is that? Common column. Therefore, I am taking this primary key SNO and this primary key PNO here as what? Foreign key. Okay friends, now you have got composite primary key with the help of foreign keys of other tables. Now what is the dependency here? The dependency I am going to write. The dependency here is nothing but S number and P number, as it is a composite key, implies what? Quantity. Therefore, quantity is a non-key and this is the candidate key. This is a which production friends? Fully functionally dependency. Okay. Now, this is also fully functional dependency. This is also fully functional dependency. And this is also fully functional dependency. You don't find the redundancy. Therefore, this is how you could convert your partial functionally dependency into fully functionally dependency. Okay, friends. Now let us write the combination. The combinations whichever are specified there, you write them. What is that? S1P1 quantity 1000, S1P2 quantity 1000, S1P3 quantity 4000, S4P1 quantity 1000. So I will write like this. The data I am writing S1, S1, S1. Please look at the original table and the S4, P1, P2, P3, P1. P1, P2, P3, P1, and here it is S4. So I am bringing the same data once again. Without data loss I am doing. Please see friends. Even you do cross join, you will get original table only. So the quantity we will take here 1000, 1000, 4000, 1000. So 1000, 1000 and 4000 and 1000. That's it friends. So you see that you don't find any kind of redundancy. The last table you are feeling that there may be a redundancy. No, obviously it is not. Why? S1P1 unique, S1P2 unique, S1P3 unique, S4P1 unique. Why? Because your S number and a P number together is what? Your candidate key. Please come to the previous example. Your original candidate key is this S number and P number only. So that one I am bringing as usually. So what do we understand friends? We understand that how partial functional dependency becomes what? Fully functionally dependency. As long as you have partial functional dependency, you are having the concept of redundancy. So you want to avoid that redundancy, use the decomposition mechanism, convert that PFD into FFD just by splitting your original table into multiple tables. Now you have got three tables friends. Now let me write the final one. You have got three tables, not a single table. Single table means you are having a partial functional dependency. Now you have three tables of your original R. What is the first table? S number city. Second table, P number status. Third table, S number, P number quantity. I am writing that. S number city. Second table, P number status. Third table, S number, P number quantity. So your single relation is split into three tables. Your functional dependency, S number implies city. This is the candidate key, hence it is FFD. Second one, P number implies status. As this is the candidate key, this is a fully functional dependency. And next one, S number comma P number implies quantity. This is also fully functionally dependency, as this is a what? Candidate key. Bus friends. So your single table, we made it into three parts and we have converted your partially functional dependencies into fully functionally dependencies. Okay. Now let us look at last example to convert your PFD into FFD. I am saying there is a R, X, Y, Z, W, and V also I will add. Your productions are Vx to Y and X to Z and V to W. So naturally we will confirm few important things. Your candidate key is a Vx. Therefore, this is a candidate key and this complete production is a fully functionally dependency. Next one. X is a part of key and Z is a non-key, hence it is a partially functionally dependency. One more, V is a part of key, W is a non-key, this is also partially functionally dependency. So we confirm there is a what? Redundancy in dependent Z and W. So what to do? Therefore, remove PFD. So how to remove? Create a separate table R1. What is that? First PFD. So your dependency is X to Z. So I have got only two particular attributes only. So here X closer will give you XZ, which implies your R1. Therefore, it is a fully functionally dependency. That's it. So as dependent Z has come, remove from your R. Next, table 2. Next, partial functional dependency VW. Bring that production V tends to W. If I am finding LHS closer, V closer, you will get VW, which is implying R2. Therefore, LHS is the candidate key and it is also FFD. Once after conversion your PFD into FFD, remove the W as dependent arrived. I am keeping LHS to make them a natural join decomposition. So R3 is the rest of the table. What is the rest of the table? VXY. So write VXY and this is done and this is done. The only one production is left, that is what? Vx tends to Y. So bring that production here as Vx tends to Y. By finding a Vx closer, I will get Vxy. It is another table by name R3 and it is also what? FFD. So after decomposition, you will understand you never have a redundancy in the tables. So no redundancy. That's it friends. This is how you can convert your partial dependencies into fully functionally dependencies. Clear? Come to next type of dependency, transitive functional dependency. The similar process we follow, same decomposition only. Bring the transitive production and make a separate table. However, you do PFD in the same way we do TD and OD also. Okay. Now observe, transitive functional dependency is nothing but there are two conditions. Non-key implies non-key. That is also transitivity only. Or one more. Any combination, we don't mind. LHS can be anything which must not be a candidate key. But RHS must be what? Non-key. That's what he is telling. X is not a candidate key. So this is not a candidate key. But y is a what? 100%. Y is supposed to be non-prime. It's nothing but non-key. So I'm putting in two different varieties. One is non-key to non-key. Other one, part of key with non-key. Any combination implies non-key is also what? Transitive dependency. What is the problem with transitive dependency? Same. What is that? Redundancy. So you want to avoid this redundancy. Try to clear the transitive dependencies by converting your transitive dependencies into fully functionally dependencies. So therefore you don't find any kind of what? Redundancy. Okay. Let us see here. This is also same definition. I told you dependent must be non-prime. Determinant can be any combination you may wish. I am writing here again. Non-key dependent must be always non-key, or another one is also there, a non-key with any combination. Non-key with any combination, LHS I don't mind, but it must not be a candidate key or a super key, which implies only what? Non-key. Okay friends, same. This is also TD. This is also what? TD only. LHS must not be a key, but RHS must be what? Non-key. Okay friends, look at one example here. What is that example is? So he is asking you to find the candidate key. So AB is going to give you will get ABC. We confirm AB is a candidate key. So what are the type of dependencies? AB implies C. As AB is a candidate key, no doubt it is a fully functionally dependency. Please observe friends. What is the next dependency? C implies D. When you say that C implies D, C is not a candidate key or a super key. It is what? Only non-key. And D is also non-key. Hence it is a what? Transitive dependency. It's not PFD. PFD means LHS must be what? Part of key. This is not PFD. It is a different type of redundancy, different type of dependency which can create redundancy. That is a what? Transitive dependencies. So another example. So what is a candidate key? By finding A closer, I will get ABC, which implies R. So your candidate key is A in this. What is the type of dependency? A implies B. As A is a candidate key, this is a fully functionally dependency. What is the next one? B implies C. As B is a non-key and C is a non-key, therefore it is a transitive dependency. So what is the problem with transitive dependency? I say the problem with the transitive dependency which leads to redundancy very similar to partial functional dependency. So how it is generating redundancy we will check in the next example. Observe friends, this is the proof. I said S number is a candidate key and there are two dependencies are given. S number is a candidate key and another dependency is S number to P number and one more P number implies city. So what is the meaning of that friends? S number, I said it is a candidate key. Already mentioned let S number is a candidate key. As this is a candidate key, it's a no doubt fully functionally dependency. Therefore, you never get any duplicates in SNO. You also can witness. Even you try to enter once again S1, S2, S3, it will give you error. So we don't want to have the concept of what? Redundancy in that. But what about next? Please observe. PNO implies city. What is a PNO? Non-key. What is a city? Non-key. Therefore, it is a what? Transitive dependency. How it is going to create the redundancy? Please observe. P1, given city is a VSP. Whenever P1 is coming, for example, you see If I am writing one more time P1 here, then 100% you have to get to PSP. No doubt it has to come. So redundancy you are facing. Another tuple is there, P2. The bound value is Hyderabad. Again, I am repeating P2 here. Then you are going to get the bound value once again. Therefore, what do we understand, friends? We understand redundancy in the form of Hyderabad city and redundancy in the form of Vizag city. Why we have got the redundancy? Because as their LHS are repeated, so RHS must be repeated. So you will understand transitive dependency is also creating redundancy. Very simple. However, PFD, whenever part of key is repeated, non-key should be repeated value. Here also, whenever the LHS is repeated, then RHS must be repeated as it is called as transitive dependencies. What is a transitive dependency, friend? I said that non-key implies non-key. Otherwise, you can take any combination. Part of key with non-key implies non-key. This is also transitivity nature as LHS is a not a candidate key. So that point we wrote here. In S number, P number, you don't have any redundancy, but you have redundancy because of what? Transitive functional dependencies in PNO and city columns. Okay. So what to do? You have to break this transitive dependency, convert this TT into FFD. Therefore, you don't have the concept of redundancy without data loss. That's very, very important. Now we will look at the proof. So what is the transitive dependency rule? Non-prime to non-prime or non-prime with or non-key with any kind of combination with the non-prime. So finally RHS must be non-key. LHS can be non-prime or LHS can be what? Part of key with non-key combination. So friends, now let us see how you are going to avoid transitive dependencies. So as per as previous table R, we have S number, P number and city. And the functional dependency is mentioned as S number to P number and P number implies city. Okay, we understand this is the candidate key and fully functionally dependency. This is the non-key and this is the non-key. We understand it is a transitive dependency. Okay, now this is the problematic production for us. So what to do? We try to do a decomposition. So one table I will make this. So your R1 is a what? P number comma city. The problematic production I am making a separate table. So bring that production. What is that production? PNO implies city. There are no other columns in R1 as it is separated from your R. Now you write the data in that. So I am writing, come to the previous S1 P1, S2 P2, S3 P2. S1 city we want to write, right? So S1 city VSP, S2 city Hyderabad, S3 city Hyderabad. S1, S2, S3. So VSP, HYD and HYD. Now we know that your PNO is going to act as a candidate key because PNO implies city means PNO is going to act as a candidate key because your PNO closer will implies your city. Therefore, we confirm PNO is your candidate key. So, no duplicates in that. Hence, this production which you are speaking, it is a what? fully functionally dependency. So as you already got the dependent, city is a dependent, you remove city from your original OR because already it appeared. So what is the next table? Only that second table is R2, S number, P number. Already this production we did, remove it, and this production you pull. What is that? S number implies P number. Now if I am finding S number closer, which is giving you P number, hence candidate key is S number. So if you write the data in S number, as this is a primary key or a candidate key, you cannot have duplicates. So you will write non-duplicate data S number S1, S2, S3. S1, S2, S3. So we need to write a P1 data here, not S1. So I'm changing what is the P data? P1, P2, P2. It's not S1. P1 data you're supposed to write. So I'm taking P1 and P2. So I don't require second this also because already we wrote the bound value of your P2. So P1 VSP, P2 Hyderabad. So here S1, S2, S3, and you know the P1 values, P number values, sir. You can write like this: P1 and P2 and P2 other values. So we will write P1 and P2 and P2. That's it, friends. So this is how you understood that transitive dependency created. Transitive dependency created what? Duplications. As like this, especially in a transitive dependency, you will find whenever P1 value is repeated, city value will be repeated. Whenever P number value is repeated, city value is repeated. That problem we eliminated here. You see that P1 unique, P2 unique, city also unique. Here also S1, S2, S3 is what? But finally, what do we understand? Your original R is decomposed into two subrelations just by using decomposition. So your original R is S number, P number, and quantity. This is divided into one R1. This is divided into R1, quantity is city, P number city, one table, and the second table is S number, P number. So production is P number implies city, P number closer. If you find, you will get P number city. Therefore, P number is a candidate key. Hence, this production which we are writing is not a TD this time. It is a fully functionally dependency. As this doesn't have any number of columns except 2. As the LHS is a key, then this production becomes FFD. Here also, we have one more production. Just I am bringing those productions only, nothing else I am doing. So if you find SNO closer, you will get S number and P number. Then we can guess this is your candidate key, and this production which you are talking, it is also fully functionally dependency. So no redundancy in this R1 and no redundancy in R2, as dependents are depends on only what? Candidate key only. This is the candidate key and this is the candidate key production, hence they becomes fully functionally dependency. In the same way, we also want to see overlapping dependency. Overlapping also generates redundancy, and we try to pull that overlapping dependencies and convert them as a new instance table using a decomposition technique, then they will become a fully functional dependency and you don't see any redundancy in the respective tables. Okay, friends. Now we will look at what is overlapping dependency. Overlapping dependency is a situation that is that is part of key implies part of key. This is an important situation. So the definition is also saying like that, that is RHS must be prime attribute, LHS can be, must not be, LHS must not be, not a candidate key or not a super key. Please understand, friends. So as far as definition concerned, let R is a relational schema with X implies Y production. We want to say that overlapping dependency means dependent is a what? Part of candidate key, part of key, and determinant can be any combination, but X must not be a candidate key or super key, any combination. Or you can also see a special situation called part of key versus part of key is the concept of overlapping dependencies. So what is the problem with overlapping dependencies? As like transitive and partial functional dependency, you will have redundancy. We will have a proof in that. Please understand again. RHS must be prime attribute, but LHS can be any combination of attributes. It can be PK or NK or anything it can be. But you say that LHS must not be a candidate key. That's the meaning of overlapping. If LHS is a candidate key, nothing else. It is a fully functional dependency only. We all know. But here LHS must not be candidate key, but RHS must be what? Part of key. So I will give you one important point. Observe carefully. When I am talking, part of key implies non-key. And when I am talking, non-key implies non-key. Or a non-key with part of key implies non-key. Or part of key implies part of key, or a non-key with a part of key implies a part of key. So what are the dependents they are? So you observe carefully what are the dependents they are belongs to. The first one straight away, it is a partial functional dependency. Second one straight away, transitive dependency. Third one is also, please understand, RHS is the non-key, so transitive dependency. Third one, part of key versus part of key overlapping. Next also, as RHS is the part of key, it's not a key. Look like very similar this and this. Please observe. This and this is very similar, but RHS is different. If RHS is a non-key, it is a TD. If RHS is a part of key, it is a what? OD. Overlapping dependence. What is the problem with overlapping dependencies, friends? Redundancy. We will show you a proof in that and how to avoid it. Understand what type of dependency it is. I am finding candidate key. So manager project closer implies R, no doubt. Because MPD, three attributes are there, MP gives D. So it's R. And here, department closer I am finding. Before you find closer, we know RHS what are missed, what are not missed. So you say that department appeared and manager appeared. The missed attribute is what? Project. So you add project here because already in the previous set project is there. Now you find the closure. This also is giving you what? R. Very special cases, overlapping dependencies. Now your candidate keys are two. What is that? Manager and project and department. There are three candidate keys. Okay. What are the dependents they are? MP gives D. This is, you all know, fully functionally dependency because MP is a what? Candidate. And you see the second production. What is the second production? Department implies manager. So what is a department? It is a part of key, not a candidate key or not a super key, but RHS is a what? Part of key. And we will understand it is a overlapping dependencies. So what is a overlapping dependency? One part of key depends on another part of key. Therefore, using this, you will have redundancy in that, no doubt. You will have redundancy in that. You don't have redundancy in this as MP is a what? Candidate key. So what to do? We want to break this overlapping dependencies and decompose your R into two tables. So therefore, both becomes a fully functional dependency and you don't find any concept of redundancy. Okay. Now let us look at the proof of redundancy there. MPD. You observe friends, we already understand two candidate keys we got. MP is a one candidate key and PD is another candidate. Okay. First production. Please look at the previous screen. Manager project department number. Manager project department number is a fully functionally dependency. What is the next one? Department manager. It is a part of key and it is a part of key and it is a what? Overlapping functional dependencies. Therefore, you will find a what? Redundancy. Why so? Let us see. The first one is manager project is a key. So we would like to see that data is unique or not. Scott P1, unique tuple number 1. Please observe. James P2, unique tuple number 2 as per as manager project only. And Scott P4, this is a unique tuple number 3 because manager project is a candidate key for us. And fourth one is James P2. Can I give James P2 friends? It's not possible because manager project is a key. Then this James P2 is not at all possible because already James P2 is provided. So remove this James and remove this P2. You want to give some other, you can give it. For example, I'm giving James. This time I'm writing P3. Now it is correct. It's a perfect. But this is wrong. Why? Because James and P2 is already available. Okay. So we understand that in fully functional dependency, we don't have any redundancy. But you observe carefully another one, department manager. So sales department, first one, no problem. So I'm writing first department and manager only. Department implies MGR. First department is a sales and manager is a Scott. Second department is accounts and manager is a James. And when I call sales once again, what is going to happen? When you repeat the department as LHS is repeated and RHS must be repeated. So here also, when I am repeating accounts, for example, if I am writing accounts here, and what will happen? James must come. So this is the problem with the word overlapping dependencies. So overlapping dependencies causes whenever LHS value is repeated, please understand, your LHS is a department here. Whenever LHS is repeated, then RHS value should repeat. So this is how. And accounts, whenever accounts is repeated, then Whenever accounts value is repeated, its corresponding manager has to be repeated once again. Therefore, overlapping dependency is going to create a what? Dependency in that. So what to do? Just bring this production, create a separate table for that. How to do? Let us see. So as far as previous example concerned, let me give the decomposition. So your R MPD, which consists of MP tends to D and D tends to M, is decomposed into two tables. One table, this is the problematic production for us, overlapping dependency. Bring it that. R1, I am making as a separate table. DM, what is the production? D implies M. No other attributes I will bring. As this is only the overlapping, we will bring that overlapping on it. By finding D closer, you will get DM, which implies R1. Therefore, D is a candidate key to R1. So friends, when you talk D implies M, this is the candidate key, and this overlapping dependency becomes what? Fully functionally dependency. Therefore, you don't find the duplications in that. Now, you remove your M from and arrived. The rest of the table is what? R2 and PD. So, your new candidate key in this is a PD, because by finding a PD closer, you will get PD. So, PD implies PD, then you don't find, as this is a candidate key, this is a fully functionally dependency. So what do we understand? Here in this R1, we will feel no duplicates. I will also give data, don't worry. And as this is a PFD, we will understand no duplicates. Why there are no duplicates? Let me write the data this time. So R1 is a DM. R1 is a DM. And R2 is a PD. And the production is D implies M. And here production is PD implies PD. Okay. So D, we made it as a candidate key. PD, we made it as a candidate key. So let us post the data. So MP, Scott, P1, James, P2. We will write them. DM na. So first DM we will write. What is the DM data? Sales Scott, accounts James. So sales Scott is the manager. For accounts department, James is the manager. We don't write one more entry. Sales will not come once again as this is the key. Accounts will not come once again as this is a key, because their other two tuples are same. You will get accounts and sales, you will get James and James. So we don't want that. So therefore, you cannot enter duplicates in that. Finally, we will understand what? No redundancy in this. In the same way, PD data we will take. What is the PD data? P1 sales, P2 accounts. P1 sales and P2 accounts. It's a new value, and one more is also there. P4 sales, P3 accounts. This is a new tuple, and P3 is also there, accounts. This is also new tuple. They are all new tuples. So therefore, we will understand no redundancy. That's it, friends. This is how you can able to understand or see that overlapping dependency causes redundancy. Just by remove that production using the decomposition concept, you will see that you don't have the concept of any redundancy, and your overlapping dependency becomes what? Fully functionally dependency. So in order to bring PFD to FFD, TD to FFD, OD to FFD is the concept of decomposition, which is one of the mechanism of normalization to prove that data is not redundant. Okay, friends. The last example, your candidate key is CH and RH. CH tends to R, fully functionally dependency, as CH is a candidate key. What about next? R implies C, part of key implies part of key. This is overlapping dependency. So this leads to what? No doubt redundancy, but in this we will feel no redundancy. So what do? We try to split it. What is the first table? R1, RC. What is the production? R implies C. By finding R closer, you will get RC. Therefore, R is a candidate key to R1. So this production becomes what? FFD. Bus. So as C is dependent to you, remove C from there. What is the rest of the table? Second table is HR. So by finding HR closer, you will get HR. Therefore, HR is a candidate key. So here also it becomes fully functionally dependent. Okay friends, so I hope so you understood and enjoy the session, how the PFD will come and how to eliminate the PFD, how transitivity will come, how to eliminate the transitivity, how overlapping will come, how to avoid the overlapping. All just avoiding, clearing those dependencies is nothing but what? Conversion of a PFD to FFD, TD to FFD, OD to FFD is the concept of decomposition. The decomposition is going to help you to clear your redundant data and so that your table is going to have non-redundant tuple set. This decomposition is one of the methodology of normalization to split a single relation into multiple relations to avoid these three problems. What are they? PFD, TD, OD as their leading what? Redundancies. Okay friends, stay tuned to us for any upcoming lectures. So I'm running this entire YouTube DBMS subject on behalf of Unacademy. Listen the lectures, subscribes to our channel and subscribe to Unacademy Plus courses and use my promo code SANKARA to get a 10% off in that, and you also join in my Telegram group. The number is 8790 for any kind of updations and any queries. Thank you very much. Stay tuned to us. Let's crack GATE ESE.